Welcome to Yupp Master. Today we are going to discuss about that the distance travelled by the light in different materials. If we are going to have a look into the matter of distance travelled or distance covered by a light in glass material, in water, in all other materials. Now if we are going to have a look into the matter of bending of light rays in different materials is at different angles, that is very clear. And you know one thing, if you are going to take the density of different materials, it is not at all same. If you are going to take that water, if you are going to take glass, if you are going to take quartz, if you are going to take the diamond, its density is going to be different, and the refractive index is also different, because the arrangement of atoms is different. So the number of atoms per unit volume, it gives the density. If you are going to have a look into the matter of refraction of light in different materials is going to be at different angles. At the same time, the speed of light in different materials is going to change with respect to density. So if we are going to look into the matter of rarer medium and denser medium, whenever the density of the material is going to be increased, what about its speed? Its speed is going to be decreases. Suppose let us take that, if you are going to take that glass material, its refractive index is 1.5. If you are going to take that water, its refractive index is 1.33. So the speed of light in glass and water material is different. How you will estimate that? Based on that density only. You can take that one example. So today we are going to discuss about that problems. Let us take that one problem. We are going to take that to calculate the distance covered by the light in water medium of 9 mm. What is the distance? 9 mm. Yeah, let us have a look into the problem. Yes, we are going to take that, they have given that time, suppose, and distance. You can easily find out that speed. Here they have given the distance. You are supposed to find out that time taken by the light to travel 9 mm in water. So while you are talking about that water, you need to have that its refractive index is 1.33. Its refractive index is 1.33. You have to remember that. Now you can have a look into the matter. So what they have given, 0.04 nanoseconds, 0.4 nanoseconds, 4 nanoseconds and 400 nanoseconds. Yeah, it is going to be its units. If it is very small, we will express in nanoseconds. Now let us have a look into the matter of that solvation. Please have a look. By taking the given data, what is the given data? Only distance, covered distance. First let us take that in the given problem, light enters from air medium to water medium. Yeah, you will take that medium. You will take that medium. Medium is water. Yeah, you have to take that medium is water. Now if you are going to take that distance covered, distance covered by the light, by the light is going to be 9 mm. 9 mm. That is, simply you can take that D, distance covered is 9 mm. Now what is your aim? You have to calculate the time taken by the light ray to travel 9 mm. distance of to cover the 9 mm distance in water, that is the case. Now, if you are going to have a look, time is equal to time taken by the light ray, time taken by the light ray, right. T is equal to T, that is equal to question mark. How do you solve this problem? Simply from your basics, what you have learned in the lower classes, you know one thing, if you are going to have a look, yeah, speed is equal to, you know very well about that, speed is equal to distance by time. So, this is the basic formula that we can use. If you are going to have a look into the matter, just you can take that, therefore, time is equal to, you can take that, time is equal to distance by distance covered by speed. You have to take that speed of light. In water. Please have a look into the matter. This is the given data and we have taken that fundamental relations and we have considered the formula. Now, if you are going to look into the matter of that substitution and further steps, yeah. So, you can take that T is equal to, you can solve for that, T is equal to, therefore, T is equal to d by speed of light in water, therefore, W in water. You have to take that. This is a simple formula, but your task has been extended to find out this one. How do you find out? D has given that. How do you find out that a speed of light in water? That is the one question, that is the one subtopic. You have to take that. Now, you know very well about that. If you are going to have a look into the matter of that speed of light in a medium is going to be related to the refractive index. Now, you can easily find out that the speed of light, yeah, you can take that. Please have a look. Yes, I am going to erase because of the limited space, erase these things. Yeah. Please have a look. Now, if you are going to have a look into the matter of the relation among refractive index, speed of light in a medium, in a particular medium, that is of mu is the ratio of speed of light in vacuum by speed of light in that medium, right. Now, if you are going to have a look, yeah, now we have been obtained that, yeah, T is equal to, finally we know that d by V in water, yeah, that is equal to, you will find out that 9 mm by, how do you find out that speed of light in water? You know, that is speed of light water is going to be identified that, well, speed by speed of light in, it is going to be identified. Why we have to consider this formula? Please have a look into the matter. Yeah, you know, refractive index is equal to C by V. Yeah, this is also water. Now, you will go for this one, V water is equal to speed of light in water is equal to c by mu w. So, you can easily find out that 3 into 10 power 8 meter per second by what about 1.33. If you are going to have a look into the calculation part, please follow the steps. Now, this is equation number 1, let us assume. This is equation number 2. You can go for the calculations, that is equal to 300 by 133 into 10 to the power of 8 meter per second. You have to get the calculation part, that is 300 divided by 133. So, initially we are going to take that 266. If you are going to get 334, 340. If you are going to take that again, you can take 2. Now, if you are going to take that further steps, you will get that 2.25 into 10 to the power of 8 meter per second. So, this is V water. Now, you can substitute very easily. Now, you can substitute in the equation 1. Now, have a look. Yeah, from 1 and 2, therefore, T is equal to 9 mm by 9 mm divided by 2.25 into 10 power 8 meter per second. So, if you are going to take the ratio of mm and meter, just you can express into meters. Yeah, just one conversion is there, that is of mm to meter. Please take that. Yeah, you have to take that. Yeah, 1 mm is equal to 10 to the power of minus 1 centimeter. That is equal to 10 to the power of you can take that 1 centimeter is equal to 10 power minus 2 meter. So, finally, you will confirm that 10 power minus 1 into 10 power minus 2 meter. So, you have to take that 10 power minus 3 meter. Yeah, therefore, 9 into 10 power minus 3 by meter by 2.25 into 10 power 8 meter per second. If you are going to get the cancellations, just you can take that. So, 2.25, 9 divided by 2.25. Yeah, that fraction value indicates 2.25. If you are going to take that, 2 is the multiple, 2 fourths, you can get this 8. 0.25 is multiplied by 4 times, you will get that 1. So, finally, if you are going to take the ratio of 9 by 2.25, you will get that 4. Yeah, this is going to be calculated, that is you will get that T is equal to, 9 into 10 power minus 3 divided by you will get that 2.25 into 10 to the power of minus 8 seconds. Please take that. It is easy to express this value, that is 4 into 10 to the power of minus 11 seconds. You will write down in terms of nanoseconds. 1 nanosecond is equal to 10 power minus 9 seconds. So, you will take that 4 into 10 to the power of minus 2 into 10 to the power of minus 9 second. You have to take this. So, 4 into 10 power minus 2 into 10 power minus 9. Yeah, you will take that. Suppose you can take that 0.04 into 10 power minus 9 second, that is 0.04 nanoseconds. Please have a look. So, in the simple problem we have solved the step by step calculation and we have obtained time taken by the light to cover the distance of 9 mm in the water is obtained by the formulas, and regarding to that refractive index and speed of light in vacuum, speed of light in the medium. So, your aim is to calculate the speed of light in the water medium. So, you have to take this formula, then it is easy. So, finally, what you have been obtained, that is 0.04 nanoseconds. Since you know very well, yeah, you know 10 to the power of minus 9 second is equal to 1 nanosecond. So, finally, you have been obtained that 0.04 nanosecond. Let us see what is the answer. Yeah, 0.04 nanoseconds is the correct one. Remaining all are not at all correct. Please have a look into this problem. This is very simple problem. So, if they are going to ask that instead of water medium, they might be asking that glass medium, but you need to know that refractive index of the glass material, that is 1.5, refractive index of quartz, that is 1.52. If you are going to take that another material like a transparent material like diamond, you know very well, that is 2.52 refractive index, you will take that, the refractive index changes. If you know the refractive index of that medium, easily you will find out that speed of light in that particular medium. So, in the entrance examinations also they are going to ask that time taken by the light to cover a distance of 9 mm. Instead of water, they might be asking that any other medium. They are going to ask that glass or quartz or diamond or whatever it may be. Just you are ready to solve the problem by knowing that refractive index of that material. So, it is better to remember the refractive index of the various transparent materials, that is very, very important. Yeah, let us go for the new problem. Yes, light travels from air to water, the angle of refraction is 30 degrees. What is the angle of incidence? Please have a look. Yeah, this is about you are finding that answer. Later we will see the options. Yeah. Now, if you are going to take that case, light is traveling from air to water. Yeah, air to water is the pair of media. That is, you will obtain that light is entering. It is going to be incidented and it is the point, it is going to be refracted, this is the incident. So, this is the normal. You will confirm that air and this is water. Yeah, light is going to be entering from rarer medium to denser medium, this is the case. So, in this case the refraction of the light will take place and it is going to bend towards the normal, this is the normal. Now, if you are going to have a look into that problem, they have given that angle of refraction is 30 degrees, angle of refraction is 30 degrees. So, this is 30 degrees, they have given R is equal to 30 degrees. So, your aim is you have to calculate this one. So, angle of incidence is going to be calculated, I is equal to question mark, I is equal to question mark and R is equal to 30 degrees. And if you know about that refractive index mu air is equal to 1 and mu water is equal to 1.33. Yeah, this is that mu W is equal to, this is mu A, let us assume, mu W is equal to 1.33. This is very important. If you know that refractive index of various materials, it is easy to solve any problem. So, sometimes they may give that, sometimes they may not give. You are all about to know that refractive index. Yeah, this is the case, but you can apply the Snell's law for the air-water boundary, air-water interface. How you will apply that? Apply Snell's law. Simply apply Snell's law. Yeah, how you can apply that? Snell's law. That is air-water interface, air-water. Now, you can start from that rarer medium and go for denser medium. So, the refraction, the angle of refraction has given. Now, you will obtain that. Therefore, mu air into sin I is equal to mu water into sin R. Now, it is very clear, they are about to know, that is refractive index of air is 1, sin I is equal to refractive index of water is 1.33, 1.33 into sin 30 degrees. Yeah, if you know that sin 30, it is going to be 1, therefore, sin I is equal to 1.33 into 1 by 2. So, you can easily find out that it is going to be knowing that 1.33 by 2, it is about 0.6, some value you will get that again 6, you will find out the 5. Yeah, 0.665, you will find out that 0.65. So, I is equal to sin inverse 0.665. This is the case. If you are going to have a look into the matter of the sine angle, sine inverse of, you know, sine 30 degrees 0.5. If you are going to have a look into the matter of that sine inverse 0.665, you can expect that inverse of this value, if you know sine inverse 0.5, it is going to be 30 degrees. So, after 0.5, what is that excessive value? 0.15. So, you might be having that guess, it is greater than 30 degrees, but not more than 45 degrees. Just we will go for that in the given options. Yeah, it is going to be in the range of 30, more than 30 degrees, but less than 45 degrees. Just if you have to look into the matter. If it is going for 0.7, you might be getting that more than 45 degrees. Please have a look into that matter. Easily you can guess the answer. While they have mentioned that 4 options, you can easily find out that, no need to worry about all these things. Yeah, what is your answer? It is a sine inverse of 0.665. Yes, in the given option 30.15 degrees, it is not correct, 60 might be not, it is going to cross that, C is not correct, D is going to be correct answer. By guessing that, you can get the all values. Please have a look. So, this is very simple and easy problem by applying the Snell's law, and finally, you will estimate that answer. At the same time, you have to remember that a light is going to be entered from A to normal, and you need to write down refractive index of air medium and water medium. So, what you are going to take that interaction phenomena, light enters from air to water medium. Yeah, while you are solving the problems in the critical angle, you have to know that denser to rarer, that enters from water to rarer medium or water to air. At the time you should remember that when light is going to be traveling from denser to rarer or rarer to denser, you have to. So, you have taken, yeah, this is the one what we have taken, sin air. By applying the Snell's law, it is easy to find out that. After knowing that, you can easily solve the problem by getting that value, yes, and the sin inverse. Please have a look. Yeah, 41.68 is the correct answer. Let us go for the next problem. Yes, it is very important question. What they have asked that? They have been asked the questions related to which of the phenomenon is going to be changed when the light entered from air medium to any other medium or rarer medium to any other medium. So, simply during the refraction, which of the phenomenon has been changed? If you are going to take that, its wavelength and frequency increases. What they have given? They have given that the couple of parameters which is going to change, which is going to increase or decrease. Surely, whenever light enters from one medium to another medium, there exists a changes. There exists a changes in wavelength that leads to change in velocity. If you are going to have a look into the matter of that light, light is in the form of wave. Yeah, it is very clear. Let us see that. Yeah, when light enters from, light is refracted into a medium. Yeah, it is good. Please take that. While you have to know that this is the light entered, this is the light entered in the form of wave. Yeah, you have to take this one. It has been refracted. Yeah, here it is going to be taking that nu is the frequency. This is the first medium and second medium. So, frequency, we are talking about that frequency and lambda. You know, frequency, you have to take that frequency is the nu, let it be nu dash, and wavelength, wavelength is lambda, and the speed of light is v. These are the parameters we have to consider. What is that case? The frequency of the incident light, this is the light wave, this is the light wave which has been incidented. The frequency of the light wave which has been incidented is dependent on the source which generates the light, the source of light which can change the frequency. The medium does not shows any effect on the frequency of that light. You know very well about that, basic formulas that you have to consider. Yeah, wavelength, its wavelength and frequency both increases. Let us take that E be the energy and E dash be the energy. E be the energy and E dash be the energy of refracted, incidented and refracted light ray. But while you are going to talk that incident light and refracted light, its energy is going to be taken as E is equal to h nu by lambda. This is the one formula you have to take that. According to the quantum phenomena, energy of the light is going to be expressed E is equal to n h nu. Suppose for one photon E is equal to, you know, that is the formula, that is according to quantum theory, according to quantum theory, E is equal to n h nu. So, n is equal to 1, E is equal to h c by lambda, this is the case. So, E1, let us assume E and E dash, yeah, this is the lambda. So, E dash is equal to h nu by lambda dash, h nu dash, let us assume. So, energy lambda, some fraction of energy has been absorbed by the transparent material. Please have a look, this is incident, right? Due to the interaction phenomenon, some part of the energy has been absorbed, it is very less. So, do you know E is less than or greater than? E dash is less than or greater than as compared to E. Please have a look. This is initial and final. Let us assume initial energy and final energy both are going to be comparable with each other, because a small change has been takes place. So, you can confirm E dash is less than E, E dash is less than E, E dash is going to be less. Yeah. Now, you can take that simply, if you are going to take that h nu by lambda is less than h nu dash by lambda dash. Now, if you are going to take that this relation, which is very important, frequency does not change, no doubt at all. So, you have to confirm that 1 by lambda is less than 1 by lambda dash, which is greater. So, finally, you will get that this is the inverse variation that leads to lambda dash is greater than lambda. Yes. So, in the water medium, due to the refraction, the lambda dash is going to be higher. Please have a look. Now, it is the detailed part. The interaction phenomena has been shown in the form of light, in the form of wave which is incidented, and refracted in the form of, right. Now, you will get that this is the refracted and incidented light. Now, you will go for the options, then only you can have that clear idea. Now, it is easy to solve the problem. Whatever they are giving you a number of options, but among all the options you will choose the correct option. Yeah, its wavelength and frequency both increases. It is not correct because frequency does not change, it is going to be wrong. Yeah. Its wavelength increases, but frequency remains unchanged. Please have a look. Its wavelength increases, so lambda dash is going to be greater than lambda. Its wavelength increases, yeah, simply that is, it is very clear, lambda dash is going to be lambda, we have obtained, but frequency remains unchanged, it is very good. It depends on the source of the light only, it does not change, that is very clear. Why the frequency does not change means it depends on the source of the light which generates the light rays, right. This is the correct. So, let us have that another options also, why they are going to be wrong. Its wavelength decreases, but wavelength decreases, that is not correct, but the frequency remains unchanged. Frequency remains unchanged, it is correct, but wavelength decreases, that is not correct. Wavelength is not going to be decreased. That. Now, its wavelength and frequency both decrease, that is also wrong. This is also wrong. Because of this point only, wavelength is not decreases, wavelength is increases, how you have been obtained. But here you should be having some observation, that is this formula, this is important formula, how you have been obtained by the properties of light according to the modern physics and quantum theory. Light is emitted by the one photon, it has been obtained by the expression which has given in 1917 Max Planck has given that explanation about that light which is emitted in the form of photon and interaction of light with the matter. Please have a look, this is the formula which plays important role. Yes, let us go for another question. Please have a look. Yeah, light ray passes from one medium to another medium. The velocity, wavelength, refractive index in two media. They have given that these are the two values, set of values. Then the ratio of sine angle of incidence, sine of angle of refraction. That is very clear. Simple problem. They have given the parameters, that is wavelength, that is speed of velocity and refractive index. Now, you know, it is a case of light enters from one medium to another medium. You will find out that this is the light. We have to take another color. We have to take with respect to normal, this is the incident and this is the refracted. While you are talking about this is the first medium and this is the first medium and the second medium, we have to take, yeah, this is the first medium and this is the second medium. They have given V1, lambda 1 and mu 1. They have given the parameters V1, lambda 1, mu 1. Here also the parameters have given V2, lambda 2, mu 2. Simply they have given. These set of parameters have the relations. You have to obtain all these relations. But they are going to ask the question, find out that ratio of sine of angle of incidence to sine of angle of refraction. That is, your aim is you have to find out that sine R, sine I, yeah, sine I by sine R. This is the question. You have to apply the Snell's law. Apply the Snell's law for two media, that is sin I by sin R. From light enters from medium 1 to medium 2, that is by Snell's law, by Snell's law you can obtain, that is mu 1 sin I is equal to mu 2 sin R. Yeah, I and R are angle of incidence and angle of refraction. So, sin I by sin R, easily you will find out that is equal to mu 2 by mu 1. So, what they have given the options, let us see. Yeah, mu 2 by mu 1, this is also correct, but this is the multi correct options. You have to look into the matter. So, you know very well about that remaining options also. Let us see. This is about mu 2 by mu 1. Now, let us have the look into the matter. Mu is equal to C by V. We know that this is the one relation regarding to the refractive index, that implies mu 1 is equal to C by V1, C is the constant, mu 2 is equal to C by V2, because C is the constant, it is going to be constant, that is 3 into 10 power 8 meter per second. It is very clear. So, this is the equation number 1, this is equation number 2 and 3. From 1 and 3, what can you get that? Sin I by sin R is equal to C by V2, C by V1. So, finally, you will get that answer, that is V1 by V2. So, what you have obtained, ratio of sin I and sin R, it is going to be V1 by V2. We have obtained V1 by V2 also. It is very clear. You know one thing, have you obtained that sin of I divided by sin of r, that is the ratio of angle of incidence to the angle of refraction. It might be having the relation with lambda, because they have given that parameters V1, lambda 1. So, we have obtained the relation in terms of mu 2 and mu 1, that is the refractive index of first and second, that is very clear. V1, V2 relation, it is over. Now, you are all look into the matter of lambda 1 and lambda 2, right. So, what is the general relation? You know, V is equal to nu lambda. Nu remains constant, it is going to be constant. Now, you can V1 is equal to nu lambda 1, V2 is equal to nu lambda 2. Now, instead of this V1 and V2, can I write V1 is equal to nu lambda 1 by nu lambda 2. Simply you will write down sin I by sin r is equal to V1 by V2, that is equal to nu lambda 1 by nu lambda 2. It is going to be cancelled. So, you may obtain that sin A by sin r is equal to lambda 1 by lambda 2. Yeah, this is also correct. So, three options are going to be having that relation with ratio of the sine of angle of incidence to the sine of angle of refraction. This is very clear. So, the basic idea behind all these three options is you have to frame that relations between V and lambda, between C and V, or among refractive index and speed of light in vacuum, speed of light in medium, that is very clear. So, from this question you can understand all these formulas, please have a look, right. Let us go for another one. Yeah, a beam of light propagates through a medium 1 and falls into another medium at an angle alpha 1. The angle of refraction they have given, I thought so. After that it propagates in medium 2 at an angle alpha 2. It propagates means by means of refraction. It has been refracted at an angle alpha 2. Alpha 1 is the angle of incidence. The light's wavelength in the medium 1 is lambda 1 and wavelength of light in the medium 2. Yes, that is very clear. Yeah, you are about to know that. Please take that. For the given problem, you can draw the diagram. So, if you are going to see the options, please, yeah, you have taken that. This is the incident light ray. Has been taken. That is, yeah, you can take that I and R. Now, it is very clear. That is alpha 1. They have given alpha 1 and alpha 2. Yeah, here, you know, alpha 1 and alpha 2. So, you can find out very easily, and lambda 1, lambda 2. They have given that. So, lambda 2 is equal to question mark. How you will find out lambda 2? So, previously what we have discussed, if you are going to take that ratio of sine of I and R, that is, it is equal to lambda 1 by lambda 2. Yeah, very simple. Apply the Snell's law. Sine of alpha 1 by sine of alpha 2 is equal to, previously we have discussed that sin alpha by alpha 1 by sin alpha 2 is equal to lambda 1 by lambda 2. That is, already we have obtained sin I by sin R is equal to V1 by V2. Yes, what we have obtained. So, this V1 is equal to nu lambda 1. V2 is equal to nu lambda 2. So, easily you will find out lambda 1 by lambda 2. In that given problem, what they have been asked that lambda 2 is equal to is equal to question mark. Lambda 2, how you will find out lambda 2? By cross multiplication you will get that lambda 2 sin alpha 1 is equal to lambda 1 sin alpha 2. Simply lambda 2 is equal to lambda 1 into sin alpha 2 by sin alpha 1. Yeah, you can check the options sin alpha 2 by, this is the option. So, how they are going to frame the problems among the parameters velocity, wavelength, frequency and angle of incidence and angle of refraction. Please know all these relations. In the coming classes also we are discussing very deeply how you will easily remember that with the help of diagrams. Thanks for your patience.